After viewing this program, you will be prepared to practice the disassembly, cleaning, reassembly, and adjustment of a constant velocity carburetor. You will also know how and when the different fuel circuits work when you're troubleshooting a carburetor-related problem. The carburetor's two main functions are to atomize fuel and air, mixing the two together as completely as possible, and to control the amount of fuel and air mixture flowing to the engine. Air enters the carburetor from the air cleaner, which is mixed with fuel in the bore, or venturi, before going on to the combustion chamber. For a detailed look at carburetor operating principles, read the booklet Honda Motorcycle Fuel and Induction Systems. Let's take a closer look at the constant velocity carburetor, starting with the body. First, we have the throttle valve, which is connected to the handlebar throttle control, the vacuum chamber, which controls the spring-loaded slide or piston, the float chamber, and the low-speed mixture screw located behind this plug. We will find out more about each of these later. Remember, when working on multiple carburetor sets, do not interchange parts between carburetors. Also, gasoline is extremely flammable, so work in a well-ventilated area away from flames or sparks. We will begin by removing the vacuum piston. Remove the 4 cover screws and the vacuum chamber cover. Take out the spring and the vacuum piston. Notice the way the jet needle tilts. This is deliberate. Tilting the jet needle by spring loading it against the inside wall of the needle jet prevents it from vibrating and affecting the mixture. Using an 8mm socket, turn the plastic jet needle retainer a quarter turn to the left. Remove the retainer, spring, and jet needle. Now, we'll just group these parts for identification. Inspect the diaphragm for cracks or tears. Inspect the jet needle for wear, bending, or other damage. The vacuum piston maintains a constant velocity of air through the carburetor bore, which is how this carburetor got its name. The vacuum piston operates over the entire throttle range, from just above idle to wide open. The piston is not directly controlled by the rider. Instead, it responds to air pressure changes in the carburetor. The jet needle rides up and down on the end of the vacuum piston and, at the same time, moves in and out of the needle jet. The diameter of the needle and the taper here are designed to increase fuel flow progressively as the vacuum piston opens. The jet needle controls the air-fuel mixture between 1/4 and 3/4 open throttle. But there is a certain amount of overlap between fuel circuits, so don't expect the needle jet, for example, to suddenly stop working as soon as the throttle moves past 3/4 open. Knowing which jet operates over which part of the throttle range is very important when troubleshooting a carburetor. If a customer complains, for example, of poor performance when rolling on throttle from idle, it would be a mistake to try to correct the problem by changing the main jet, since the main jet does not even begin to operate until after 1/2 throttle. Next, remove the float chamber screws, the float chamber, and the O-ring. Now we can see the float, float pin, float valve seat, main jet, low-speed jet, and bi-starter jet. Notice the angle of the main jet and the low-speed jet. They are set in at an angle from the axis of the carburetor and from the needle jet. The result is a smaller, more compact carburetor. The float chamber acts as a fuel reservoir, providing a constant supply of fuel for the carburetor jets. The float is designed to maintain this fuel at a predetermined level. As fuel is consumed, the float opens the float valve to replenish the fuel supply. Remove the float pivot pin. Float and the float valve. Next, remove the float valve seat and filter. Inspect this filter for dirt and clean as necessary. So now we have the float chamber disassembled. Remove the main jet and emulsion tube. The main jet supplies fuel from about 1/2 to full open throttle. The larger the number, the richer the mixture. Air supplied from this passage enters tiny holes in the side of the emulsion tube and partially atomizes the fuel before it leaves the needle jet. This helps produce a better atomization of the mixture. The needle jet is pressed in and is not removable. Remove the low-speed jet. Notice it has its own emulsion tube which receives air much like the main jet. The slow or low-speed jet controls the air-fuel mixture from idle to about 1/4 throttle. We can now group these parts together. These holes are part of the bypass fuel circuit, which acts as a transition between the top end of the low-speed jet range and the lower end of the needle jet range. The bi-starter jet is part of a mixture enrichment circuit for cold starting the engine. The bi-starter jet is not removable, but the bi-starter valve is, so we will now remove it. The bi-starter operates like a mini carburetor within the larger carburetor. It has its own separate air supply and its own separate fuel supply from the float chamber. The purpose of the bi-starter is to give first a rich mixture and second a fast idle. For a detailed description of the bi-starter circuit, refer to the booklet Honda Motorcycle Fuel and Induction Systems. On certain models of Honda motorcycles, the bi-starter valve is equipped with this needle. These models include the CH-125 scooter, the GL-1200 Interstate, and the Aspencade. The low-speed screw is located behind this aluminum plug. For removal, the plug must first be drilled. Make certain you have the right plug. Use brass tubing over the drill bit to prevent the drill from hitting the low-speed screw. Use a 4mm drill bit. Carefully drill through the plug. It is hollow, so penetration depth should not exceed 1 millimeter. Insert a sheet metal screw and pull out the plug. Remove the low-speed screw. Inspect for signs of wear or damage to the tip. The low-speed screw controls the amount of atomized fuel entering the carburetor bore. It is used to set the idle mixture. The low-speed screw adjustment is critical for good engine operation and is covered in Module 2AB. Now we can see the primary fuel-air mixture circuits and their parts. 1 is the float chamber. 2, the bi-starter valve. 3, the float assembly. 4, the low-speed jet. 5 is the vacuum piston. 6, the jet needle. And 7, the main jet. Cleaning can best be done by simply spraying carburetor cleaner into the air passages and the openings of the carburetor body. Check that none are clogged or obstructed by dirt or varnish. Avoid soaking the carburetor body in cleaners or solvents, as this may damage O-rings and plastic parts not removable from the body. Remember, handle jets, vacuum piston, and other parts with care. They can be easily scored or scratched. Reassembly is basically the reverse of disassembly. Be sure to replace all O-rings. We will start with the low-speed screw. Notice the very fine tip on the end of the low-speed screw. Handle carefully. It is easily damaged and should be replaced if bent, scratched, or has a grooved end. Note also the sequence of spring, washer, and O-ring. Reversing the order of the O-ring in the washer will cause an air leak. Caution, damage to the low-speed screw seat will occur if the low-speed screw is jammed against the seat. Remember not to install a new plug until after the low-speed screw has been reinstalled and adjusted. Refer to your shop manual for the initial setting. Reinstall the bi-starter valve. Do not screw it in too tightly. None of the parts should be over-torqued. Just seat it in tight. Now the low-speed jet. And the main jet. Reinstall the filter on the float seat. And then reinstall the float seat. And now reinstall the float valve, float, and float pivot pin. Remember, correct float level is critical to proper carburetor operation. Now that you've reinstalled the float pivot pin, you can reinstall the float chamber, the needle, spring, and jet needle retainer in the vacuum piston. Insert the piston in the chamber and make sure the diaphragm is seated properly. Once that's done, you can reinstall the vacuum chamber cover. In review, air enters the carburetor throat and is mixed with fuel. The vacuum piston controls the rate or velocity of air entering the carburetor bore. The float chamber provides a constant supply of fuel to meet throttle needs. The low-speed screw controls the mixture from idle to 1/8 throttle. The bypass ports and the slow or low-speed jet circuit control the air-fuel mixture from idle to 1/4 throttle. The jet needle controls the mixture from 1/4 throttle to 3/4 open. The main jet controls the mixture from 1/2 throttle to full open. And the bi-starter circuit operates from idle through the full throttle range, but is most effective from idle to 1/4 throttle. For exact specifications and procedures, always refer to the shop manual for the motorcycle you're working on.
Complete the worksheet that is identified for this video. If you need assistance, see your instructor.